Hey guys, welcome to part 2 of the notes. I know these are pretty long videos, especially when you're home by yourself, but I wanted to get through all of this information because all of it's on worksheet number 1 in the Chapter 8 worksheets. And so please make sure you've checked out both videos, gone through the notes so that you have everything you need to complete that worksheet. So we're going to continue moving on with the graphing portion, but now we're going to work specifically with this function f of x equals ax squared plus c. So before we were only working with ax squared, but now we're going to have that plus c. And all the plus c does is shift vertically, either up or down. If it's a positive number, it's going to move it up. If it's a negative number, it's going to move it down. So it's kind of similar to the k that we used to work with when we had those h and k's with our absolute value functions and other ones we've used. Same idea as the k. It's going to shift it up and down. So when c is greater than 0, we know that this is a vertical translation, is what we call it, vertical shift, up c units. So when c is greater than 0, vertical translation c units up. Now, when we have a c less than 0, so it's going to be like ax squared minus c. So when c is less than 0, then we have a vertical translation c units down. So just like it would normally move, it's going a negative number on the y-axis would go downwards. It's going to do the exact same thing. So just things to keep in mind as we go. It also then will affect our vertex. Before, all the functions we worked with had a vertex of 0, 0. It's now going to have a vertex of 0, comma c. So whatever c is. So if it's a positive 4, it would be 0, comma 4 for the vertex. If it's a negative 3, it would be 0, comma negative 3 for the vertex. But the axis of symmetry is still going to be the x equals 0, so the y-axis or h of x axis, whatever we're working with, is still going to be the axis of symmetry because x value is still 0. It hasn't shifted left or right. It's only moved up or down. So just some important information to keep in mind as we go on. So we're going to do 4 of these together. We'll walk through for a second the steps of them, and then we'll actually go in and do them. So if you want to flip your page over to the next part of your notes, that's the one we already did, excuse me. So flip over onto this next one. Now our steps for actually graphing these things is no different than what it was before. So we're still going to follow that 3-step model where we are going to create a table of values. We are going to then plug those values in for x's to get our y values or our function values. Then we're going to plot the ordered pairs and then draw a smooth curve. Now on this one, they've actually asked us to compare the graph to the graph of f of x equals x squared, so to its parent function. So we're actually going to have to draw 2 graphs on this. But the great thing about f of x equals x squared is it never changes. It's always going to be the same. It's going to have a vertex of 0, 0, points at 1, 1, negative 1, 1, and then points at 2, 4, and negative 2, 4. So it'll be fairly easy to work with on that. So we can still follow that exact same method for the table of values. We can still do everything we need to on that side from there. And so first thing we're going to do, go in and create that table of values. So draw your chart. Again, you can do vertical, horizontal, however you want it to look. I like the horizontal. That's just me personally. But it's going to have 2 rows, 6 columns. Hopefully I feel like a broken record saying it, and you feel like that as well because it's ingrained into your memory forever and ever. So label it x and g of x. And so then we're going to go in, and first thing we got to do is do the vertex. Well, now our vertex is slightly changed. The x value still going to be 0 because it is not shifting left or right. But this negative 2 affects our y value, essentially, or it's the g of x value. And so when it is 0, g of x is going to be negative 2. And if we just think about that, 0 plugged in for x, we get 0 squared, which is 0, minus 2 is negative 2. So we are essentially going to be shifting down 2. So we have a vertical translation by negative 2. So now I still need to pick 2 points to the right, x values, 2 points to the left, so I'm going to keep it simple, and I'm going to go with 1 and 2, which means I'm going with negative 1 and negative 2. And then I'm going to plug those in. So when I have an x of 1, so g of 1 equals 1 squared minus 2. According to PEMDAS, got to do the exponent first. So 1 squared is 1 minus 2. 1 minus 2 is negative 1. So when x is 1, g of x is negative 1. Now I'm going to put in my 2. So when x is 2, g of 2 equals 2 squared minus 2. Well, 2 squared is 4 minus 2 is 2. So when x is 2, g of x is 2. And then again, I can plug this in for the other values, but they should come out the exact same. When I have negative 1, I should get negative 1, and when I have negative 2, I should get positive 2. But let's just check just to make sure it still holds true with this new change. So g of negative 1 equals negative 1 squared minus 2. Well, negative 1 squared is 1, minus 2 is negative 1. So it still worked for that one. Let's check the other one. G of negative 2. So I've got negative 2 squared minus 2. Well, negative 2 squared, negative 2 times negative 2 is positive 4. Minus 2 is 2. So it did hold true. It did exactly what it was supposed to. So again, when you do your assignment, I need to see the table of values. I need to see these two. You don't have to show me these two. That's assumed by the mirror reflection across the axis of symmetry. Those are going to line up. So now I need to go in and I need to plot those ordered pairs and label my graph. So first point, 0, negative 2. So 0 on the x-axis and down negative 2. There's my vertex. Then I've got a point of 1, negative 1. So right 1, down negative 1. Then I've got a point of right 2, up 2. Then the same on the other side. Left 1, down 1. And left 2, up 2. And again, they should look like mirror images. So there is my graph. Now I need to, again, smooth curve, draw it as best I can, make it look like a parabola, arrows at each end. And again, this is my g of x. Now the reason I got to label this, and I'm going to put a highlight around it just to make sure it's really obvious what my g of x is I'm going to have to draw my f of x. Now I don't need to see the table of values for your f of x. You should know this. It's pretty simple. But if we just worked it out, and I'm going to put it on this one just to see it. If we just worked it out really quickly, we'd have, again, same thing as always. 2 rows, 6 columns, x, and this is f of x. And when f of x equals x squared. So I'm just going to make sure I make that obvious. So when I put in 0 for that, I get 0. Choose my points, 1, 2, negative 1, negative 2. When I put 1 in here, 1 squared is 1. When I put 2 in here, 2 squared is 4. Same thing happens on the other side. Negative 1 squared is 1, and negative 2 squared is 4. So that would be the table of values if we just wanted to see it. Well, now I have to go in and I have to graph those actual points. So vertex at 0, 0, points at 1, 1, and 2, 4, points at negative 1, 1, and negative 2, 4. So then I can go in and I can draw my parabola. It should line up pretty closely with the other one. Draw it as smooth as possible. Right there. And so now I've got that. I'm going to go in, I'm going to highlight it just to make it obvious that this is my g of x. You don't have to highlight it, I'm just trying to make it easier to see. And again, this is f of x. And so that's my f of x right there. So now it's asking us to compare them. So what it's asking is what happened from the original parent function of f of x equals x squared to get to what the new parabola looks like. Well, again, we don't even really need to look at this to figure that out. We can simply go to the a's and the c's to see what's going on. Well, my a is 1, and 1 does not change it at all. It keeps it the exact same. And if you look at those, they pretty much look the exact same in terms of their width and all of that. So nothing going on there. But what I do have going on is my c, which was my -2. And we learned that this causes a vertical translation, or as we might say, it vertically shifted down by 2. Because my original function here, my yellow one, f of x, was at the point 0, 0. Well, this one is now at 0, -2. And if you look at it, every point actually moved down 2 spots. So what was 2, 4 is now 2, 2. What was 1, 1 was now 1, -1. So it was vertically shifted down by 2. And that's for this one all I really have in comparison. All right, so let's take a look at example B. We'll do this one again together and follow along as you go. So here we go, B. So we've got h of x equals x squared plus 3. Then they want us to compare to the graph of f of x equals x squared. Well, if you wanted at this point, you could really just go in and draw the f of x equals x squared. So I'm going to go in and do that right now. So I've got 0, 0, 1, 1, 2, 4. -1, 1, and -2, 4. So there we go. I'm going to draw my parabola as best possible. Smooth curve as much as possible. Arrows, label, f of x. And I'm going to highlight it just to make it obvious. So there we go. So I already got it drawn on, don't have to worry about it. So now I just need to go in and do my table of values for the h of x function. I need to plug those numbers in, solve for the h of x or the y values, and then plot the ordered pairs and draw my parabola. So first things first, create my table of values. 2 rows, 6 columns. Should really write like a song about that, right? So here we go, x and h of x. So again, x value still going to be 0 for my vertex, and that's my starting point. But we've got this y value of c value of +3, and that affects it. It's going to shift it, as we've learned, up 3. So if I plugged 0 in for x squared, I'd get 0 plus 3 is 3, so my h of x value would be 3. So my vertex is going to be at 0, 3. Then I need to pick 2 points to the right, 2 to the left. We'll keep it simple. 1 and 2, -1 and -2. And then I need to plug them in. So I've got h of 1 equals 1 squared plus 3. Well, 1 squared is 1 plus 3 is 4. So when x is 1, h of x is 4. H of 2, so equals to 2 squared plus 3. Well, 2 squared is 4, and plus 3 is 7. So when x is 2, h of x is 7. And then I need to mirror that image across, so that would be 4, and that would be 7 as well. Again, you can always work those out on your paper. Does not hurt to, but it's going to follow that pattern every time. So as long as I pick the same points on each side, I'm good to go. So now I need to plot those ordered pairs. So start with my vertex of 0, 3. So don't move left or right, but move up 3. So 1, 2, 3. There's my vertex. Then 1, 4, so right 1, and then up 4. And then 2, 7, so right 2, up 7. and then -1, 4, and -2, 7. And again, remember, they're just mirror images, so it should be pretty easy to find those points. Well, now I got to draw my line, or draw my parabola, excuse me, smooth curve, so as best humanly possible. Draw it in, label it. This is my h of x. And as we look at it, pretty obvious that same width, everything going on is the same. It's just simply shifted upwards by 3, which is obvious just looking at the equation. There's no a in front of x at this point. It's just a 1. Doesn't change it. It's not shrinking or stretching, but it has shifted up by 3. So again, if they asked me to compare it, I would say vertically shifted up by 3, period. And that's all that's really going on with that one. So let's move on to example C. We're going to get a little bit more complicated with now something other than 1 for A, which is going to cause both a vertical stretch and shrink, which you've seen before in the previous 4 examples. And then we're going to also still have that shift up or down going on. So at this point, I would encourage you, pause the video, try it on your own, then play the video and see if it matches up with what we came up with on the notes. So I'm going to shift my paper up, much like the parabola on the last one was shifted up, and we're going to get started. So again, starting with the same, I'm going to go ahead and get my f of x equals x squared on my paper. So points were 0, 0, 1, 1, and 2, 4, and then -1, 1, and -2, 4. Draw my parabola and label it f of x. Get that taken care of. So that part's already done. So now I'm going to go in and worry about my h of x. So I need to draw my table of values. So again, 2 rows, 6 columns. And I know some of you are bored, so if you can come up with a really good song about that, I might get some extra credit on that side. So x and h of x. Now I need to figure out my vertex. Well, x value at this point still always 0. Well, what's going on with my c value, because that tells me what it's going to be? Well, it's adding 1, so there's my h of x value right there. So 0, 1. That was all that really happened at this point with my vertex, as it just shifted up 1. So now I'll pick 2 points to the right, 2 to the left, keep it simple, 1 and 2, and then -1 and -2. So from there, I now need to go on and plug these numbers in. So I've got h of x, or h of 1, equals 4 times 1 squared plus 1. Well, PEMDAS says exponents first, so 1 squared is 1 times 4 plus 1. Well, next would be multiplication, so 4 times 1 is 4, plus 1 is 5. So when x is 1, h of x is 5. Now on to the next one. So h of 2 equals 4 times 2 squared plus 1. 2 squared is 4 times 4 plus 1. 4 times 4 is 16, plus 1 is 17. Now here I may have made a little error in terms of graphing that f of x function first, because I probably needed to relabel my graph in order to fit all of these points on, because I have a point at 17. For the sake of time, rather than redoing this, I'm just going to just pretend that those points are on the graph and go from there. But it's really important, guys, don't get ahead of yourselves like I just did. Wait to graph that f of x, because we ended up with a point that's really large and we would have needed to relabel the graph. So again, if we're mirror images, this should be 5 and 17. So it should fall into the same. So now we need to go in and graph it. So first point, vertex is at 0, 1, so just shift up 1. Second point, 1, 5, so right 1 and up 5, 1, 2, 3, 4, 5. And then 2, 17, so right 2 and up 17. Well, this is 11, 12, 13, 14, 15, 16, 17. So it's like way up in here. So that's, again, an error on my part. On your assignments, you need to relabel. I'm going to put that out there right now. Unless you're going to barely have to extend the graph like we did on one of the earlier examples, you need to relabel. So don't get ahead of yourself with graphing the parent function. So again, on the other side should be the same. So negative 1, 5, and negative 2, 17. So right up in there. So there we go. Draw my smooth curve as best possible. Now this one looks a lot skinnier, but remember when we go to compare this why that is. And so I'm going to highlight it just to make it obvious. This is my h of x. So there's my h of x. Now when I compare these, I really don't even need to look at the graphs to figure these out. And sometimes looking at the graphs can actually create more confusion because it looks like this is getting skinnier, skinnier. But what's really going on, as we know and learned in the first 4 example problems, is we've got this 4 right here. That's our a. And when that a is not incorporated inside of a parenthesis with the original function of x squared, that means it's dealing with vertical stretch and shrink. And when a is greater than 1, we have a vertical stretch. So it's getting taller, taller, taller. Not skinnier, 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 but taller, taller, taller. So when I look at this, I know that I have a vertical stretch by 4. That tells me it right there. I also know that I had we vertically shifted, or we had a vertical translation up by 4. So vertically shifted up, not by 4, excuse me, by 1, which was right there. And if we look at the graph, we can definitely see that part of it. So vertical stretch by 4, vertically shifted up by 1. So those are the things I can look right here and determine all that. I could write this before I even plotted and graphed all of this. I could look at that and tell those 2 things are going on. The a, when not in parentheses, talks about vertical stretch or shrink. So if this number is greater than 1, and we don't include the negative in front of it, so if it's greater than 1, it's a stretch. If it's less than 1, it's a shrink. This number right here is going to tell me if it's going to shift up or down. And then if we were to have a negative out in front right here, that would tell me reflection across the x-axis, and my parabola would then be pointed downwards. All right, so we got one final example, example D. I would encourage you again, pause the video, try it on your own, then check it against mine. So I'm going to flip the notes over here, and we're going to jump on to final example here. So we want to graph h of x equals 2x squared minus 5, then compare the graph to the graph of f of x equals x squared. Well, I'm not going to get ahead of myself this time and start graphing f of x. I'm going to wait and hold off this time. So I'm going to start with my h of x, and I'm going to choose ordered pairs, create my table of values so that I have ordered pairs that I can plot. So table of value, draw it in there, 2 rows, 6 columns. X and h of x, right there. First one, I need to figure out x always going to be 0 at this point. My negative 5 tells me my y value or my h of x value if we plugged 0 in for x, which is negative 5. So I know that my vertex is shifting down by 5. I can already tell that, again, just by looking at the function itself. So then 2 points to the right, 2 to the left, so 1 and 2. Negative 1 and negative 2. And now we go in and we plug those in. So h, when x is 1, equals 2 times 1 squared minus 5. Follow our PEMDAS. So exponents first, so we get 1 squared, which is 1, so 2 times 1 minus 5. Then multiplication, so 2 times 1 is 2 minus 5. 2 minus 5 is negative 3. So when x is 1, h of x is negative 3. Then go in and do the other one. So h of 2 equals 2 times 2 squared minus 5. So 2 squared is 4 times 2 minus 5. 2 times 4 is 8. Minus 5 is 3. So when x is 2, h of x is 3. And again, should mirror that on the other side. So we should have negative 3 and 3 right here. Again, always can plug it in and check it if you're not sure. So now let's go in and let's graph this. Luckily the numbers were small enough here, I don't have to relabel the graph. So I could have done the parent function first, but just to be on the safe side after the mistake last time, make sure that I don't do that. So here we go. First point, 0, negative 5. So 0 on the x, down 5. 1, 2, 3, 4, 5. Plot that point. Next point, 1, negative 3. So right 1, down 3. Next point, 2, 3. So right 2 and up 3. And then my mirror image side. So left 1, down 3. And left 2 and up 3. So there we go. There's my function. So now I need to go in and I need to draw my smooth curves. Create my nice parabola. That might be my best one yet. I'll let you guys be the judge of that. So that is my h of x. And again, I'm going to highlight it just to make it obvious. So there we go. Now I need to go in and draw my f of x on there. Because when they ask for the comparison, that's both a visual and a written comparison. So points at 0, 1, 1, and 2, 4, negative 1, 1, and negative 2, 4. And then draw my line, draw my parabola. So here we go. Now you may notice this one kind of overlaps a little bit. And that's okay. That happens. Parabolas can do that based on vertical stretches and shrinks. So now I'm going to go in. I'm going to highlight it just to make it obvious which one's which. And then I need to label it. So this is my f of x in the yellow. Now last thing, let's give that written comparison of the two. So again, I don't even like to look at the graphs. I just like to look at the function itself and say, hey, what's going on with it? So first things first, I've got my a of 2. Well, that is greater than 1, and anything greater than 1 tells me I have a vertical stretch. So this is vertically stretched by 2. And then I need to look at my c, so what's behind the x squared? So minus 5, that tells me that I am vertically shifting downward, because it's negative, vertically shifted down by how many? 5. And so now I've got my comparison. And that's really all there is to it in worksheet number 1. It's just an extension of itself. We start with that basic ax squared function, and then we add the minus or plus or minus c, which then allows us to know if it's shifting up or down. And then don't forget, if you have a negative involved, that again, as always, is a reflection across the x-axis. Well, I hope this video helped you out. If you have any additional questions, please feel free to call me on my cell phone, 918-605-5402. Text me whatever you need help with. You can also email me at my school email address, joseph_yeisley@gfps.k12.mt.us. If there's anything I can help with, happy to set up a Zoom video, Google Hangout, FaceTime, whatever it is to help you. Please reach out if you do need that help. Otherwise, stay safe, stay healthy, and we'll see you again soon, hopefully.